Okay, in this section, we are going to look at an introduction to integration, which integration is just the inverse of the derivative, which is why it's called anti-differentiation. And then the indefinite integral, that means we'll get into definite integration later on. So all of these you definitely want to memorize. If you notice, all of these are the inverses of the derivatives. Like, for example, the derivative of sine is cosine, so the integral of cosine is sine. And so that the elongated s represents the term for sigma or summation, and we'll get into again later on what that means even further. And in this section, you'll see some of the summation signs as well. Okay, well, we did that in class, so let's go ahead and look at example 1. Find the general solution for the differential equation. So you're finding what function has the derivative that is equal to 2. That's what we're looking for in this particular problem. Look to see if you can't think that one through. What function has the derivative? When you find the derivative, its derivative is 2. Try that and then come back to the video when you think you have it. Okay, so if the derivative is 2, we are looking for the antiderivative, which is the original function, and so that would be 2x, because remember the derivative, this represents the slope. And an equation with the slope of 2 is just going to be 2x. However, the general solution, now remember, you can find the derivative of 2x plus 1, and it's 2. 2x plus 11 is 2. 2x plus 111 is 2. So you have to account for all of those possibilities. That's why it's called the general solution. So that's where you would add a plus a constant. So that c represents, so right here, that represents a constant of integration. Okay, so on this one, this would be our final answer. That's the general solution of this differential equation. So then if we just look down here, we already talked about the constant. This is the function, right? The original function. Do it in red. That is the function. Okay, and again, this is the function, which is the derivative, or the integrand. This right here, this x represents, so this is the change. This is like delta. Some books will show you a delta instead of a d. But delta x, the x is the variable of integration. Okay, and then this is your original function. So after you integrate it, this would be your integrated function. So let's write integrated function. Okay. So just some more basic rules, terminology. You can look through this. This is what we just looked at. When you, like right here, you have the derivative. When you integrate the derivative, then you have the original function. Just different ways to write the same thing. This means the same thing as well, right? The derivative of the integral is the original function. So the derivative in the integral, this is the integral sign. The derivative and the integral end up canceling each other out there. All right, because they are opposites. So this and this cancel each other out, leaving you with just the original function. Okay, let's go ahead and try this example. Just finding the derivative. Don't forget to think about what function has the integral, or sorry, the derivative that's equal to 3x. So think about this, pause the video for as long as you need, try it, and then come back to see how you did. Okay, so you're looking for the original function. And when you integrate this, you're going to end up with 3 halves x squared plus c. And you can check to make sure that's right. So if I find the derivative, okay, I would bring this down, so it would be 2 times 3 halves x, and then that constant will cancel out, and that simplifies to 3x. So I know that I'm right. On this one, this is my final answer. Looking down at example 3, on some of these, it's going to be easier to rewrite them first and then integrate them. For example, if we look at this first one, we can rewrite this as, instead of 1 over x to the third, we can rewrite it as the integral of x to the negative third. And always have that dx that shows what variable you're integrating. It might seem tedious and unnecessary now, but later on when we integrate with different variables, it becomes very important. So just get in the habit of always including that change in x, or if it's a change in g, whatever that variable of integration is. Now, looking at this, there are different rules for polynomials. You have to think about what function is going to have the derivative that equals that. Well, the one trick is, remember, it's the opposite of finding the derivative. So the last thing you do for the derivative is going to be the first thing and the opposite of the integral, meaning the last thing is you would subtract 1 from your exponent. So the first thing we're going to do is add 1 to your exponent. So then it becomes x to the negative second. And the first thing you do is multiply by your exponent when you're finding the derivative. So the last thing we'll do is divide by your new exponent, which is negative 2. Okay, and so we always have that plus c. And then we just simplify that. And that can be simplified as just negative 1 over 2x squared plus c. And that's our final answer. So when you're integrating polynomials, remember you would add 1 to the exponent right here. You add 1 to the exponent and then divide by that new exponent. Okay, everything is complete opposite in reverse to finding the derivative. Okay, so go ahead and try the square root of x on your own, just the square root of x. Pause the video and then come back. You should have changed that to the integral of x to the 1/2, and then when you add 1 to your exponent, that gives you x to the 3/2, and then we divide by that new exponent. And then when we rewrite that, it would be 2/3 x to the 3/2 plus c. And that would be our final answer for that one. Okay. Now for these, when it's a constant, for sine, when it's a constant, we can just pull that constant out front and just focus on what is the integral of sine of x, meaning what do I find the derivative of to get sine? And in fact, that is negative cosine, so it would be 2 times negative cosine of x plus c, and we can simplify that just by multiplying that 2 and negative cosine, so it would be negative 2 cosine of x plus c. Okay, now for this one, you can break this up to see, so pause the video and try this next one right here on your own. See if you can break this up in a way that you can integrate it as 2 separate polynomials. Pause the video, try it, and then come back. So when we split that up, this is what it's going to look like. You would have x over square root of x plus 1 over square root of x, and then you can break that up into 2 separate integration problems. So you'd have the integral of x to the 1/2 and the integral of x to the negative 1/2 once you simplify these back here. And then you add 1 to both exponents and divide by that new exponent, and that gets us over to here. And then just kind of rewriting it however you want to rewrite it. This is going to be 2/3 times the square root of x to the third plus 1/2 square root of x. And that's pretty much as far as we can go, or as far as we're going to take this. Oh, plus c. Don't forget that constant. Okay. We'll do one more for this particular video. This one, I want you to look in that table that we had looked at the beginning and think about how can I break this problem up into one of these integrals. So you're trying to break it up into one of these integrals where you can find the integral and know what it is via this table. All right, so again, we're looking at integrating sine x over cosine squared x. Pause the video, try this on your own, and then come back. Break it up into sine over cosine times 1 over sine, which is equivalent to tangent secant. And then if you look at that table, the integral of tangent secant is just secant. Because the derivative of secant is tangent secant. All right. So that concludes this intro video. We did a couple examples. In the next video, we'll do some more examples as well as a word problem, kind of bringing in some velocity.